here you see the stations. In this case, this is direction finding systems. Provides the bearings on the signal. This information is constantly generated by all these measurement devices and sent to the server, which processes it, aggregates, reduces the noise, and finally calculates the locations of the emission sources. Let me enable them. So here, these points, they represent the results of the emission source coordinates calculation provided by server. Apart from that, I can add the ellipse layer to provide some information about accuracy of measurement. The direction finding system used in this case is a high performance systems. They generate about several thousands of signal detections. It produces multiple measurements of the same signal with some accuracy, which leads to such a picture when we have some cloud of points instead of 1 point, for example. This server analyzes this large number of points produced by the devices and calculates the most probable location point. This leads to the situation when these multiple points are replaced by a single point, which is called cluster. Using the filtering options, I can remove the spare objects and leave only the clusters. As you can see, the picture became much clearer. So now I can see only these large circles. Each such circle, which is a cluster, it represents a multitude of these single location points, which are processed by clusterization algorithm. But I can use this tool. I can specify the interval, for example, of 15 minutes, which makes 30 seconds blocks. So I can move to the very beginning when I started observing it and explore what was going on in each period of time. You can see that the picture is changing when I'm moving the bar. The information about the current time for the current position of the pointer is depicted evidently here in this bar. If I hover each cluster, I get the detailed information about the type of signal source, the transmitter, the central frequency, the bandwidth, the coordinates of this emission source, latitude and longitude, the bearings, the azimuths, the values of azimuths of the bearings that are used for calculating this cluster. And the list of frequencies of multiple points that were used to calculate the position of this cluster. Okay, let us explore this source of signal. So now I have this object and I can see how it's moving. And anytime I can create manually the target. I can create it exactly at the point where I want, or I can ask the server to calculate the most probable location of the target. Then I select the target tool, specify that the position shall be recalculated according to the coordinates of each cluster. Let me specify the lifetime. And now I see the first target. Here it is. Then let me move a bit forward in time. And here is the next position of this object. Let me create the next target, also with recalculation. So now I see I have 3 targets. So the object was moving from this one, then to target point 2, and then to target point 3. All the targets can be explored in this table, so I can remove them and create a new target, or I can export them as JSON file for subsequent processing. Let me depict the jammer stations. here that were created. So imagine that we have these two jammers over this territory and found this object. So I can see that to jam this object, I don't need jammer 2. I will use jammer 1. And if needed, I can change azimuth. For example, here. We see that the azimuth was changed, or I will point the object to jam it.